So we are going to be continuing on with triangle congruence, and today we are looking at ASA and AAS. This first one is going to be angle, side, angle, and then we have angle, angle, side. And in both of these we have two angles and one side. So this is going to be where order is going to matter. So we're going to start with ASA. So if two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the triangles are congruent. And remember, included means that the side between the angles. So I have that one side in between those two angles. So if my first pair of angles, angle A is congruent to angle D, so we have that little mark there. And then we have that side in between the two angles, so we have side AB is congruent to side DE. I have that little hash mark there so we know. And then that second angle, so we have angle B is congruent to angle E. These two here. So if we have that angle, side, angle, with that side being in between, side is in between those two angles, then we know triangle A, B, C is congruent to triangle D, E, F. So we're going to look at number one together. So we have this picture over here, this nice little kite. And we are given SQ bisects angle RQT and angle RST, and we want to prove that triangle QRS, that top triangle, is congruent to triangle QTS, that bottom triangle. So statement one, SQ bisects angle RQT and angle RST. That is going to be our first given. Then we have angle RQS is congruent to angle TQS. So we have RQS, this angle here, is congruent to TQS. And the reason for that is going to be definition of bisector, because we have SQ bisecting RQT, so it's cutting it into two congruent angles. Then we have angle RSQ. RSQ, this one over here, is congruent to angle TSQ. So this one here, those two. And the reason for that we know is also going to be definition of bisector, because again SQ is bisecting angle RST, so it's cutting it into two congruent angles. Then we have QS is congruent to QS, so that's going to be that middle line there, that shared side between the two triangles. We know a shared side is going to always be congruent, and if we have the same thing on both sides of our congruent side, that is going to be reflexive property. Think of a mirror, reflexive. And then lastly we have triangle QRS. QRS is congruent to triangle QTS, and the reason we know that is going to be ASA, angle, side, angle. Angle, side, angle. This is where that side is in between the two angles. That side is in between the two angles. Now we are going to move on to angle, angle, side, or AAS. So if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the triangles are congruent. So if we have two angles and then a side that is across from those two angles, side is across from those two angles, then it's going to be angle, angle, side. So our first angle, angle A, is congruent to angle D. Then we have our second angle, angle B, is congruent to angle E. And then our side that is across from those two angles, we've got side BC, and then side EF. So if we have an angle, and a side across from those two angles that are all congruent, we can say that those two triangles, triangle ABC, are congruent. So triangle ABC is congruent to triangle DEF. Alright, so going over number 4 with you. So I have YZ bisects angle WYX. Angle WYZ is congruent to angle YXZ. And we want to prove that triangle WYZ is congruent to triangle XYZ. So these two triangles are congruent. So statement 1, we're always going to start with our first given. So we're going to have YZ bisects angle WYX. And that reason is going to be given. Then we're going to go ahead and put down our second given statement. So we have angle YWZ is congruent to angle YXZ. So we have YWZ is congruent to YXZ. So those two angles are congruent. That is given. Then we're going to go off of our first statement. We have YZ bisects angle WYX. And if something bisects it, it's going to cut it into two congruent angles. So we can now say that angle WYZ is congruent to angle ZYX. And we know that because of definition of bisector. Now we're going to say that side YZ is congruent to side YZ. We can come to that conclusion just by looking at our picture because that's a shared side. Anytime we have a shared side, it's going to be congruent to itself, and that is going to be due to reflexive property. Same thing on both sides, like a mirror. And then lastly, statement 5, we're going to say that triangle WYZ is congruent to triangle XYZ, and we know this due to angle, side, angle, side across from those two angles, angle, side across from those two angles. So this is where order definitely matters when you're doing these. And just a little something extra for those of you who are actually watching my video lessons every day. I have given you the statements for each question you are doing for the rest of today. I'm going to show you question 7 in a moment. And this way I'll know who's actually watching these also.